We will discuss about the index formula computation in this lecture. Index formula is actually about finding out the address of a particular element in the array. When given an array and its base address is known to us. Base address means the address of the first element in the memory, and we are interested in finding out the address of particular element. So suppose we have a one-dimensional array. There are some of the assumptions here. For example, let's say this is the A array, and this A array has some size. Let's say the A array is of U size. Okay, and the first index of the array is, let's say, L. So L is to U means that the first index of the array is L and the last index of the array is U. If I say in this array, then L is this one, then obviously L plus 1 will be this one, L plus 2 will be this one, and so on and so forth. The last element will be at U index. The second last element will be at U minus 1 index, and the last element will be at U index. If you want to find out how many elements are there in this array, then there will be a formula for this: U minus L plus 1. Why is it so? Why we have taken it as L minus U plus 1, U minus L plus 1. If you start counting for a number from 1 to 10, let's say the number is from 1 to 10, then the number of elements will be 10. Okay, if you take 10 minus 1, then it is 9, but how many elements are there? It has 10 elements. So 10 minus 1 plus 1, meaning that there will be 10 numbers. Similarly here, if the upper bound is U, it means the last index, and the lower bound is L, then the total number of elements will be U minus L plus 1. Right? Okay. Suppose we have some assumption. Let's say the address of the first element is alpha. It means, let's say, address of A1 element is, let's say, alpha, or AL element, in fact. Right? Now we are interested in finding out the address of some AI element. For this, let's take one assumption initially. We will remove that assumption later, that my first element is at index number 1. Let us assume that the first element is at index number 1. Obviously the second element will be index number 2, and so on and so forth. So let's say my assumption is that the first element is at 1 index. So the address of A1 element is alpha in this case, after the assumption. The address of the second element in this case will be alpha plus 1. Address of the third element in this case will be alpha plus 2. Address of next element will be at alpha plus 3. Now about the address also, we have taken an assumption that every element is requiring only single byte for the storage. This is our assumption. The first assumption is that my index starts at 1. Next assumption is that every element requires 1 byte for the storage. We will remove all these assumptions later. Now similarly, if you want to find out the address of some ith element, so this will be alpha plus, see, if we are finding the address of the fourth element, then it is plus 3. For 3 it is plus 2. For 2 it is plus 1. Similarly, for I it will be alpha plus I minus 1. So alpha plus I minus 1 is the address of some ith element with the assumptions. Now let us remove the first assumption, that every element does not require 1 byte for the storage. It requires more than 1 byte. So if it requires more than 1 byte, so let's say an element requires n byte for the storage. So if it requires n byte for storage, the address of the second element will be 1 into n, alpha plus 1 into n. Address of the second element will be alpha plus n, which means alpha plus 2 into n. Address of the fourth element will be alpha plus 2n plus n, which means 3 into n. So the address of ith element will be alpha plus I minus 1 into n. Now the second assumption was that every element is, the first index of the array is 1. So let's try to remove that assumption also. Now say if the address of the element is not starting from 1. If the address of the element is starting from 1, then the first element is at 1 index, second element is at 2 index, third element is at 3 index, fourth element is at 4 index. And then if we want to just find out the ith element, so the index of the ith element is I. Means ith element is AI. Now if the address is starting from L, then L plus 1 will be second element, L plus 2 will be the third element, and some ith element, we need to find out the distance of the ith element from the first element. Right? The distance of the ith element from the first element. So if you want to find out the distance of the fourth element from the first element, so this will be 4 minus 1 plus 1. It means the fourth element is 4 distance apart from this. Similarly, for the ith element, it will be I minus 1 plus 1. So it is I distance from here, from the first element. Similarly, if the indexes are starting from L, then the ith element will actually be, or the I index will actually be I minus lower bound plus 1 distance from the L. So again this is minus, so this is equals to alpha plus I minus L into n. If we take just one more example just to explain this, how this is done. Let's say the first index is 0, and we just need to find out how far the ith element is from the first index, or how many elements we actually bypassed, or how many elements we actually crossed to reach the ith element. Let's say we are thinking about the four index element, index number 4. So index number 4 is actually 5 elements away from the first element, 5 elements apart from the, or fifth, it's the fifth element from the first element. So how did we find that? 4 minus 0 plus 1, upper bound minus lower bound plus 1. So this is fifth element. Similarly, the ith element will be I minus 0 plus 1 distance. So if we have to find out the address of the ith element or AI element, then we had alpha plus I minus 1, assuming that the first index is starting from 1. When we are removing that assumption that now the index is starting from L, so I index element will be I minus L plus 1 element from the first element. Right? So we have replaced this I with I minus L plus 1. Already we had minus 1. So this minus 1 and plus 1 had got cancelled out. And now we have the index formula for ith element in the 1-dimensional array. Fine. Now let's take a numerical question. Say there is an array of which has a first index is minus 1 and the last index is 10. Let's say the address of the first element is 2000. Every element, let's say, requires 4 bytes for the storage. Then we have to find out, let's say, the address of 7th element, A7. So the formula for the ai element will be alpha plus I minus lower bound multiplied with n. So this will be equals to alpha is 2000 plus I means the 7, lower bound is minus 1 multiplied with 4. So this will be equals to 2000 plus 8 into 4 means 32. So the address is 2032. Right? So this will be. Thank you.